Welcome all of you to the lecture number 3, BSc 534, Legislation Aspects of Fire Safety Management. Today, we will try to look into the codes review, which is in fact the prescriptive code. In the first lecture, I have introduced the fire safety regulations and fire safety management. Today, we will try to look into more details of the prescriptive code. Now I'm going to share the screen, okay, with PowerPoint. Okay, in this lecture, I will try to cover the prescriptive code, and at the end of the meeting, I will talk about the assignment, which I have just uploaded to the assessment, okay, in the Blackboard, okay. And I think after the airdrop period in the first 2 weeks, the student have already confirmed in choosing this subject. Okay, so I assume that all of you will stay behind for the rest of the semester. Okay, thank you. Now, this lecture will cover the regulation for fire safety. Of course, as the topic or title of the subject, it's legislation aspects. So some regulations, ordinance, code of practice will be covered. The prescriptive code for fire safety, a review on code of practice for means of escape. Okay, in fact, the code of practice for means of escape is one of the codes of practice summarized in the code of practice for fire safety in buildings 2011. Okay, so this is just one of the codes of practice in this FS code. Okay, and we also have a further introduction on the code of practice for fire safety in buildings, which is more related to the passive design. Okay, and after that, we have the performance-based fire codes for fire safety. We have a review of development of the performance-based fire codes and an example. Okay, if time is allowed, I will also cover the example today. Now, why do we need regulations or codes? Have you ever thought of why we need it? Or the other way around, if there are no codes of practice or regulations, what will happen? The design may be over provided, or in case of the budget cut, okay, there will be less sprinkler heads or other provisions as required, okay? It's normally required. So we I usually use well, an example on like playing some board games. We need to follow some rules and regulations. Otherwise, there will be no path or no correct route to follow, and everyone will play the game whatever in which way they like. Okay, so we need to have regulation and codes also for the fire safety provisions in buildings or premises or in some infrastructures. Now, for the building and development control, we need to have sufficient and adequate safeguards. Okay, we need to make sure that the building will not collapse under loaded or structure loading. It will not allow the fire to spread easily or the smoke spread easily. In some cases, we have confinement or compartmentation, which try to confine and limits the smoke from its origin, fire origin, and have some safeguards, okay, provided for the structural wall and partitions and floors also have separations between different stories in a building. Promotion of commonwealth, okay, stability, that means they should be stable, okay, have sufficient stability. If it is weighted, okay, if we have some weight on it, and normally the wall, the structural floor, for example, we have some furniture, we have us, the occupant, we have other, say, doors and staircase, etc. We need to make sure that the stability of the elements, the wall or the floor slabs, have structural stability. That means underweighted, they are not easy to collapse. Safety of users, okay? We need to make sure that safe egress or evacuation routes are available for the occupants, the users, okay? The occupant may include the staff or the visitors at the shopping center, or the traveler or the guests at the hotels, okay? And we also have some users that may be having lower mobility, that is in wheelchair or walking sticks, etc. Okay, so safety of all these users, their types and their characteristics have to be paid attention to. Health, comfort, and convenience of the occupier. We need to ensure they having good, say, the IEQ, indoor environmental quality, have thermal comfort and convenience. Also, for example, the barrier-free access, which allowed the certain width of wheelchair or the standardized size, okay, to pass through, and make sure that they provide convenience to the occupants or the occupiers. Protection of the environment. Also, we have the environmental protection. Even when fire occurred, they may have polluted air, okay, or hot, dark smoke, which may be toxic and released to the environment, which makes a pollution to the air. So we need to focus on these buildings and development control. Now, we also have different controlling method. Either we have the building ordinance and the allied legislation. So if you remember, we have chapters for the laws of Hong Kong. For buildings ordinance, we have chapter 123, okay, chapter 123, under laws of Hong Kong, or e-legislation. Okay, if you type in e-legislation Hong Kong, you will have available search engine. Okay, so those subsidiary legislation under buildings ordinance, there may be buildings requirements on the number of fitments or number of utilities, like those wash basin or water closet or urinals for the male and female toilets, okay? And other statutory control are also controlling method, which govern by the number of occupants inside the premises, and also determine the number of facilities required, okay? And say in some of the legislation, they mention just for example, every 25 occupants will have a wash basin or water closet. Okay, so if you have 100 on that particular floor, you will need 4 of them. Okay, and female and male requirements are different, so it will listed in the allied legislation, statutory regulations on the sanitary fitments required. And the major prescriptive control of fire safety. Now, for the buildings ordinance, it is considered to be the construction and the spatial design. Okay, the structural provision, like means of escape, MOE. We have the FRC, fire resisting construction, and also the MOA, means of access for firefighting and rescue. Means of escape mainly for the occupant to evacuate from the building. Okay, we have the fire of origin happened or occurred in the room. Okay, and those nearby or inside the room will be evacuated first, and they will pass through the aisles, the corridors, the staircases, etc. Okay, so the spatial design, which also determine the number of, for example, we have small rooms, we have corridor, okay, which allows access of the occupants to evacuate from the premises. So the corridor width, okay, we may have the travel distance. For example, if we have occupant here, they need to evacuate either this way or in this way. Okay, and we also have the staircases, okay, which is available or protected lobby provided to prevent the smoke generated from spreading towards the evacuation route, which should be a safe space. Okay. Sometimes the staircase will be pressurized, okay, in order not to allow the smoke to spread. But the pressurization of staircase need to pay attention to the pressure head, the bar, which is available inside the building, or else if the pressure is too high, okay, then the occupant may find it difficult to push the door open, okay. So all these are related to the structural design or the construction, building construction. Fire resistant rating or fire resistant period, okay, consists of the duration that the partition or the wall or the floor steps can withstand a certain duration of fire effect. For example, 30 minutes, 60 minutes, 120 minutes, and 240 minutes, which is available for this fire resisting construction. Means of access also related to the building construction, which is the accessible staircase for the firemen and firemen's lift, or we have the access for firemen with the emergency vehicular access, EVA. Okay. Now, how about the Fire Services Ordinance? Okay, Fire Services Ordinance, with its name, Fire Services, it relates to fire services installation. So common types maybe water-based system, sprinkler heads. We have the sprinkler, which use water as the medium. So we have the water-based system. We need to have the water tank for storage of water. We need to have the pumps to deliver the water from lower level to upper levels, especially we have high-rise or skyscrapers. Okay, we also need the fire service installation to, say, detect the fire. We have fire detection with different types of detectors, heat detectors, smoke detectors with different operating principles. You may have learned more in the fire engineering systems subject, DSC 532, earlier or next semester. We also have the hydrant and hose reel, which also use water as the extinction medium. Okay, again, we need the tank, the pumps, the pipe work for delivery. We also have the hydrant. For example, we have the hydrant landing valve, which allows the firemen to plug their tubings to fight the fires. And we may have the street hydrant, which allows the water to be pumped through the major pump for the engine, okay, to deliver the water through the FS inlet, okay, the FSC net to the building. We also have alarm bells or alarm which have the flashlight or the syringe, which notify the occupants to evacuate in a timely manner. Okay, smoke control is another fire service installation, which control the amount of smoke generated, extracted away, lowered the risk and increase the visibility and which may hinder the evacuation of the occupant, and also extract it to minimize the suffocation of the occupant. So you can see buildings and fire services are two major aspects for fire safety. Now, let's look at the prescriptive code for fire safety. Now, in the prescriptive code, it states or set forth the minimum requirement for the protection generic by the occupancy. What does that mean? So the minimum requirement that in the FSI codes of practice for the active fire service installation, we have particular systems for certain premises. For example, low-rise hotel. Okay, the number of requirement, for example, 16. Okay, we have the audio visual advisory system. We may have sprinkler system. We may have hydrant hosiery system, etc. So in those, we need to provide it as the minimum standard. Okay, we must provide it according to the codes. It is generic by the occupancy that depending on the occupancy, that is the usage of the building or the premises, whether it is a hotel, as I've just mentioned, or it is an industrial go-down building, that is a kind of factories. It may be commercial building, that is for office or business. It can be domestic building for residential purpose that people living in. Okay, so different occupancy or the usage will have different minimum requirement of the fire protection. Also, the spacing of requirement for detectors and sprinklers and their interaction with other services, such as the detector on sensing the presence of smoke may cut off the oxygen supply and switch off the mechanical ventilation or air conditioning systems with fresh air intakes, etc. Okay, sprinklers also have interaction with smoke control system in sometimes. Okay, we need to have spacing requirement. So for sprinkler system, we may have different occupancy or hazard classifications. For light hazard, we have some combustible, which is of little or less dense, less fire load. Okay, for ordinary hazard, we have ordinary combustibles and ordinary fire load density. For high hazard, okay, we have combustibles that are of high combustibility, and requirement of the sprinkler head separation may varies. Okay, the sprinkler heads for light hazard may be wider. Okay, whereas ordinary hazard, the area covered or by each sprinkler may be about 12 meters square, and the separation is 2 to 4 meters. Okay, whereas for high hazard, okay, it is 9 meters square. Okay, or light hazard is 21 meters square regarding the area covered by each sprinkler head. Okay, so maybe the 9 meters square can be drawn smaller, okay, to illustrate the differences. Okay, so the spring heads are expected to be closely packed, okay, than the ordinary hazard or the light hazard. Now, this will affect the coverage, okay, the coverage by the sprinkler. Okay. And also the tank size, the volume of water should be provided, and also the pump size of the sprinkler system, which for the pump set, we need to provide the pressure and the flow rate specified. That specify fire resistance. Okay, fire resistance, as I've mentioned, consists of the fire resistance rating. For example, 4-hour fire resistance rating will usually provided in a basement, okay, where we should make sure that the structural walls, etc., should have 4-hour fire resistance rating. And sure, because the occupant have to evacuate upwards, and also the firemen trying to go downstairs in the basement to rescue may not have openable windows to evacuate or escape, okay, or rescue the occupant. We need to bear 240 minutes to ensure no collapse of the structure at basement. Maximum travel distance. This is also an important factor. In consideration, there was research study about the breathing apparatus of the firemen. How long can it stand when they go into the fire scenery to rescue occupant? Okay, and the travel distance, also the location of the occupants will also affect the duration that they are allowed to be saved. Smoke control in atrium. Large atrium usually found in hotel lobby or shopping arcades or shopping mall. So those atrium, which is large space at the area, okay, which may allow the spread of fire and smoke easily if no smoke control is installed. Okay, for example, the fire occurred in ground floor may have spread to the upper stories. Okay, if there is no proper insulation or fire curtain or smoke curtain being installed. And that may also depend on the volume of the atrium. So these are some prescriptive codes requirement. Now for the review of codes of practice of means of escape, it's mentioned that it plans sufficient escape routes and adequately protecting them. Okay, sufficient in a sense that the number of occupants present should have a certain number of evacuation route or evacuation stairs or exit doors, and they should have sufficient width of the corridor. First, the number. Second, the width. Okay, should be provided sufficient number and sufficient width of the exits, and staircases should be provided. And adequately protecting in the sense that structural protection, the stability, integrity, and insulation have to be provided. Planning to prevent the spread of fire. Okay, we have some walls to subdivide the large premises into smaller rooms and to control and remove smoke and combustion products in the evacuation route. Okay. Sometimes we may consider smoke extraction fan available, or we have a fan which allows the individual partitions which separates the compartments, try to extract the smoke and heat, okay, so that the toxic gases will not spread to adjacent rooms. There may also be other combustion products, okay, we may, depending on the combustibles, what materials is consist of. Ensure by design, construction, finish, equipment which the building will provide adequate fire-safe background for the provision of means of escape. Okay, so we ensure the means of escape. In fact, if you look at the Cook's requirement, which is available at the COP HKBD, for example. The Cook's design and also the manual, okay, Cook's of practice and design manual. We can see the code of practice from MOE, means of escape, which is an out of date version. Okay. 1996. Okay. And we also have another one, which is the fire resisting construction. And one more, which is the means of access. Okay. Which is 2004. And all these have been combined together to become the code of practice for fire safety in buildings. Now, let me take the MOE first, means of escape. Now, the legal requirement mentioned that the requirement for MOE, means of escape, for the buildings are laid in the section of 41 Part 1 of the Building Planning Regulations. Now, Section 41 Part 1, Building Planning Regulations. Okay. E-legislation, Hong Kong. Chapter 123. So this is the board buildings ordinance. Okay, for the buildings ordinance, we have different subsidiary legislation. It's personal or original have 56. Okay, 56. And there's some definition, some others. Some terms, okay, definitions provided for different regulations. And we also, let me see, subsidiary legislation. Okay, so we have 123A up to 123Q. Okay, so these are also the references we have for the building ordinance. Okay, so the subsidiary legislation. Now, the one that I've mentioned earlier, standards of sanitary fitments. The sanitary fitments, number of water closet fitments, the number of water closet, okay, the WC, number of person of the residential buildings, or we have the number of person in commercial buildings, etc. Okay, the number of fitments may be determined. The number of water closet fitments and urinal provided for male persons in workplace. Okay, 11 to 100 people. Number of fitments, 1 every 25 male person, or part of those persons being provided, which I've mentioned earlier. Okay, so just want to let you know the details, okay, as stated to the requirements. Lavatory basins, not more than 100, then 1 every 25 female person being provided. Okay, so now we have the building planning regulation. For building planning regulation, 123F, okay, the 123F building planning and interpretation, what is the meaning, and others, okay, have description. We also have guidelines on the section 41, part 1. So if you throw in 41 part means of escape, okay, it mentioned that the building shall be provided with sufficient means of escape in case of emergency, okay, which is required with intended uses of building. And there may be access staircases for firemen, okay, the access for firemen, which is allowed safe and unobstructed means of access. That is the route for all the occupants in the building in case of fire. So the firemen can have no obstruction in accessing to the building. And also access staircases number should be adequate and had to be intended use of the building and size of each floor. Adequate number of firemen with equipment to reach the fire, and also have the staircases to be adequately protected by fire and smoke. Now 41B, fireman's lift, okay, is also provided. So 41 part 1 is governing, okay, by the requirements on a staircase, fireman's lift, firefighting and rescue staircases, which are provided with 30 meter in height and cubical extent of 7,000 meter cube, and a story of the height of 1 story. Okay, whereas the basement have another criteria in effect. Last but not least, we have the emergency vehicular access, EVA. Okay, it allowed the safe and unobstructed access of the vehicle. Vehicle, in a sense, we have the fire engine or fire brigade being provided in case of emergency or fire, and operate with the vehicles. Okay. So this is the provisions, and guidelines and code of practice is being mentioned. Now, basically, all the buildings except those exempted from Buildings Ordinance Control and paragraph 5.1 of the code have additional requirements. Now, what is the additional requirement? Those requirements, as we may have fatal accidents occur earlier. For example, the bed space apartment, okay, have the bed space apartment ordinance, Chapter 447. We have child care, okay, child care centers or ordinance chapter 243. Education premises, education ordinance chapter 279. Factories, industrial undertaking ordinance chapter 59. Number 5 is hotel and guest room and guest house accommodation ordinance 247. Number 6, residential care homes for the elderly. So you can see that 6 of them have different characteristics. The bed space, apartment, crowded, let space allowed it for the occupants who just have the bed space, one closely packed with another, okay, or having the different layer of beds in the apartment. Child care, okay, some kindergartens or even infants or babies, which may not have sufficient consciousness, they need nurses or caring, say, people to take care of them. In case of evacuation, they need assistance. Education premises, maybe for adult or primary schools, in university campus, okay, that have education needs or different students, different types of students available. Factories and industrial undertaking, F&IU, okay, which may be use of machineries. Occupants may be familiar with the environment, but still there are particular concern with regard to the factories and industrial undertaking. Hotel and guest houses, the type of occupant is usually transient. That means they are not familiar with the environment and they may have slipping risk. So in case of fire, they may have less consciousness and they need to have or possess smoke detectors present in each guest rooms and have the alarm gone, which notify the occupants when they are sleeping. And clear evacuation route layouts, okay, available at the home and the room back door. Residential care homes, okay, for the elder person, okay, RCHE ordinance, which needs again nurses to help and assist the occupant to evacuate. Okay. Now the MOE code not applicable. There is some exception. For example, those not more than 3 main domestic story, not more than 13 meter, or use of the occupancy by single family. Okay, single family domestics. Okay, so for these 3 criteria, we will not find this applicable. Now, first factor to consider is the occupant behavior and distribution pattern. Okay. Behavior in the sense that what are their activities being held in the building. Distribution pattern is the number of occupants inside the premises, whether they are crowded together or they're scarcely apart. Say, for example, behavior. As mentioned, they can be transient. They may have the slipping risk. They may have awareness or consciousness. The mobility may also affect, okay, the behavior, okay, transient, sleeping risk, consciousness, mobility, etc. Okay. Now the pattern, distribution pattern, whether it is crowded or scarce, kitchen may be an area that is not too crowded, expected, but the area serving food or having the guests present, different tables closely packed, or the waiters or waitress may have different patterns, or even the area having toilet or the corridor may have less persons assumed. Assessment of accommodation. We have different parts as a guide to assess the requirements of means of escape. For example, capacity and population of the space. Now we have the table for a number of occupants present inside the premises. Now, factors representing usable floor area in meters square per person. That means each people occupy how many meters square. Usually, for example, we have the office building or office 9 meters square per person. Now, if an office area is having 80 meters square, having 9 meters square per person, PPL per people or person, then we have the capacity around 9 persons. If it is 900 meters square, there will be 100 people. Sorry. Now, restaurant. Restaurant calculated dining area, where the people dined and have meals together. 1 meter square per person. Whereas kitchen, every person have 4.5 meters square. Now, for the general requirements of exit routes, all the exit routes to be directed to the street, which is an ultimate place of safety. So it can be an open area, or can be a back lane in the street. It can be near the main entrance, etc. Okay. Now, from some of the sections in the means of escape or the fire safety in buildings code of practice, it mentioned that it should not close with door or gates unless the door or the gates are capable being readily opened from inside without the key and in the direction of exit. So the movement of the evacuee or the occupants is going from left to right in the diagram. So the door should be wedged open outward, so in the same direction as evacuation. And from the code of practice for fire safety in buildings, clause B 5.2, it also mentioned that the door should not be closed, or the entrance or the exit should not be closed with doors and gates unless the door or the gate are capable to be readily opened from inside. And again, in the direction of exit without use of keys. Okay. So we make sure that it is not locked. Okay. Sometimes safety in evacuation with respect to security is contradicting. In some cases, we want to make sure that the evacuation routes and escape routes are 3 to be opened without key. But on the other hand, we do not want strangers from getting into the building. So we may have the push bar, which allowed the occupant to evacuate, but again, has sound the alarm to notify that occupants are evacuating. Every exit routes to the street or open area at ground level have unobstructed access. That means the width should be greater than the total width of all the exit routes discharging to such area. Okay, we need to make sure that as we assume 1,000 occupants to evacuate at a certain width of exit, should not overload it, okay, and should not have 1,500, say the occupants will not evacuate in sufficient time. Exit routes leads to rear lane, the back lane of the street. This is from the sections 8.5 to 8.6, 450 mm return and not to obstruct or reduce the width of exit should be provided as in green. Okay, so the evacuation route is escaping in the direction of to the back lane or the private lane. Okay. How long? Okay, properly paved. Now, public or the private lane where the right of way exit and free of obstruction should not be blocked by the rubbish bins or path of loads nearby. Okay, no, it shouldn't be avoided. And no door or the gates to be installed at point unless open from inside or without the use of key and in the direction of exit. Now, for the design parameter for the building layout, we try to look at the capacity of the room and the story. We noted the floor area of each story, okay, and we noted the number of exits minimum of the exit door, which have the minimum and maximum width of the exit door and exit route. There may be stairs available, and here there may be another stair. Okay. Distance to travel, that is the travel distance or direct distance, the time to reach the temporary safe place. We have the discharge value, which we will look into more details later, and the width of the exit, geometry of the exit route, okay, whether it is in zigzag way or it is just a direct evacuation route. So these are some of the parameters. Where the exit door and exit door from the story, the flats, or each story, and the premises or the room, or like us, we are in the lecture theater, we have 2 exit door, okay, which give access from this room to an exit route outside the core J to core F and J. And we have the evacuation route, or the exit route, which is a route where the people in any story, like this is the 3rd story of the building, may reach a place of safety outside the building, like the podium level, which is outside of the building, include rooms, doorways, corridor, staircase, area of refuge in refuge floors. In higher buildings or taller buildings, we may have refuge floors available for the temporary stay of the occupants. Now, from the code of practice for fire safety in buildings, the exit route means the continuous path of travel from any part of the building to the ultimate place of safety. Okay, the final one, not including revolving door, lift, or escalator. Okay, so usually the final or ultimate place of safety includes the open area. Discharge value. Discharge value refers to the number of persons that a staircase of a given width may be assumed to be able or capable of discharging from a given number of stories. For number of stories, 7 stories, for example, we have a given number or capable to discharge a certain number of occupants for 7-story premises. Of course, that also depends on the area. As mentioned earlier, we have the number of persons checked, okay, because we have each person occupying 9 meters square, say, okay, and we will try to assume, for example, 900 meters square will give you 100 people, each 9 meters square per person. Okay, and then we have this in a certain story, and if we have multiplication of the stories, the width of the staircases will also increase. Let me see. There is a discharge value table for reference in later slides. When we go through it, we can have more detailed investigation on that. Direct distance, which is not found in the Code of Practice for Fire Safety in Buildings. Now, direct distance is where the distance measured in straight line along with the notion path from part of the room to the center of the exit door. Okay. So direct distance, according to the Code of Practice of Means of Escape, we have maximum distance of 18 with degree more than 30-degree angle, okay, which allows 2 exits to an alternative exit at more than 1. Okay, so in case one is blocked, we have a fire nearby, we use another one to evacuate. Okay, alternative staircase, alternative point of discharge. Dead end distance. The overall length of the travel distance within one exit route before the alternative exit is available. So for the single room, we have maximum 15 meter. That alternative door is not provided. And the direct distance should not exceed 15 meter. That is a maximum. Now, this diagram shows the direct distance, the travel distance, exit doors, and that line, that end. Let me see if I enlarge. Okay. Now, if we look at the diagram with internal corridor access, you know that the direct distance, maximum 15, as mentioned, D1, smaller than angle 30, and this is greater than angle 30 in D2, which is maximum 18. Okay, we have D1 also here, which is have 1 exit door only, whereas here we have 2 exit doors for a larger room and another 2 exit door, okay, available. Okay, the travel distance is considering from the exit door to the exit to the staircase. Okay. We have, say, travel distance, D6, or staircase separation, D3 to D3 plus D5, which is from the midpoint of the travel to the staircase to the other staircase. Okay, midpoint. That end is D1 plus D4, which is maximum 18. Okay, so in fact, similar to the code of practice for fire safety in buildings diagram B2, use that end travel instead of direct distance. Okay, so it listed extracted from the means of escape code of practice from the code. Now, limitation on direct distance and travel distance for buildings with 2 or more staircases. We have these maximum sum of direct distance and travel distance being noted for different types of building, office, shops, schools, or other case. So other than office, schools, and shops, it belongs to other cases. And there are different types of exit routes. Okay. Here is the external balcony approach. So this is the external, this is open staircase. This is the balcony, which lead to the evacuation of one exit door and 2 exit door respectively. Now for this one, they are without internal corridor. So it is just some rooms directly exit to the staircase and have the travel distance measured. Internal access requirement. Now A and B together given in table 4 should within 30 to 45 meter. Okay, and we have the escape route having the floor level with minimum 30 lux level. Okay, with the artificial lighting system. Okay, we have some lights, luminaire, lamps, etc. Whereas the backup by emergency lighting provide 2 lux. Okay, horizontal illuminance on the floor level with 2 lux. Now exit from the room. Okay, capacity of room or the story will give you different number of exit door. Okay. Now, how to determine the number of exit door for a room? For example, 4 to 30 people. And then we have 1 exit door. Okay. If more than 30, that is 31 to 200, there are 2. Okay. And depending on the total width being given, okay, even though we have 2 exits for 3 category of occupants, they may have different width of the exit door and total width of the exit door and exit route being given. Okay. So 1.05 is the maximum for 2-story, two exit door or exit routes, whereas 1.2 is an other, okay, available for the occupants. So the number of exit and minimum width of the exit door and exit routes are in table 2 of the MOE code. Capacity more than 30, 2 exits. Greater than 30-degree door swing in the direction of exit. That means in the same direction as going out of the door, the room. Door swing should not reduce minimum required width of the exit door. So even though the swinging of the door should not obstruct the means of escape. Now for width of staircase, no stair should have a clear width stipulated table 2 discharge value should not less than the capacity of the building as in accordance to the means of escape codes. Okay. Now here it's mentioned about the discharge value calculation. P is the discharged value. N is the number of staircase. And C is the capacity of the building over ground floor, given in table 5 and 6. Okay. Table 5 and 6, in fact, determined by whether it is a sprinkled or non-sprinkled building. Now for table 5, non-sprinkled building, okay, number of stories served, for example, 7. The width is 1,200. There will be 468 people. Okay. So the discharge value will increase as the number of stories served increase. And it will also increase when the width of the staircase increases. For a sprinkled building, okay, number of stories, 1,200, 708, which is having a relatively larger number of occupants or discharge value as compared with the non-sprinkled building. In fact, for sprinkled building, it helps to extinguish or control the fire or suppress the fire in a shorter manner. So it allows larger number of occupants to be available to discharge or to evacuate. Okay. And if you look at another example, office building with 9-story high, sprinkled building contain 5 number of 1,350 stairs. The maximum capacity and the number of staircase, 855. Since it is a sprinkled building, we look at table 6. Table 6. Okay. 9-story building. That means it has 8-story. Okay. Excluding the ground floor. There's 8-story covered. Okay. Total 9-story. There's a ground floor. Ground floor. So 8 stories in total. So we look at the 8th floor. The exit width, the width of the staircase is 1,300. So 1,300 is this one. So we read through this one and read through 8-story. It's 855. 855 each. And now we have 5 numbers of staircases. So approximately 4,275 people. 8-story above ground floor. So the C value should be reduced by a reduction factor 0.7 for Caesar staircase. Okay, by experiment and research study, we noted that if Caesar staircase, what it meant by that, Caesars, like the Caesars we are using, okay, and 較剪梯, so it has the construction, something like on the right-hand side, the Caesar staircase. And it is found that a reduction factor of 0.7 is noted without any intermediate landing between 2 consecutive floors. Okay, if it is just a regular staircase, we have one exit from each floor and then go to another floor, and etc. Okay. But for Caesar staircase on same floor, there are 2 exits door available on each floor. On each floor. Okay, now we still have Let me see. I may cover staircase and then let you have a break. Let me see. 7:43. Okay, 5 more minutes. Now, staircase construction in the building planning regulation, as mentioned, it is one of the subsidiary legislation, 39, okay, of the building reg ordinance, prescribe the requirement of the staircase with vertical egress purpose. Okay, staircase well or shaft is vertical evacuation up and down. Of course, evacuation is usually downwards, whereas basement have upward evacuation. Okay, this is the basement, for example. Okay, this is okay. And according to the code of practice of means of escape, stipulates the requirement of construction of the staircase. Okay, there's special attention paid. Transfer to other staircase, there should be 2 or more exit stairs if the building, except domestic building, less than 15 story. People use one staircase shall be gain access to at least one of the other staircases, okay, without passing through the private premises. So there should be 2, okay, at least 2 or more, either 2 or more than 2. Now, such access should be provided at each floor where the refuge floor are provided, okay, and at the refuge floor or the roof. Sometimes the roof is also provided as the refuge purpose. Protection of smoke effect on the required staircase, protected lobby. Okay, sometimes there may be double leaf of doors available before entering the staircase. Okay, and the use of common corridor, common lobby, utility area, maid quarters are protected by protected lobby is not acceptable. And the discharge value of the staircase should be greater than the total capacity of the building. Okay, so the allowed number of occupants evacuate from the building in the staircase should be larger than the total capacity of the building. That is the number of occupants, okay, inside the building. Table 5, non-sprinkler building. Table 6, sprinkler building. Okay, if the exit direction is upward, that is for the basement, we have factor of multiplying 0.8. If it is a scissor staircase, multiply 0.7. Okay, it is considered as a study. Building planning regulation 39, building exceeding 4 story. Second staircase or continue to the roof should be provided. And the separation between the staircase should be less than 48 meter. Maximum 6 story, below or equal to 6 story, we can have single staircase. Uppermost story less than 17 meter above ground level. Roof for refuge. Okay, this is the number of occupants permitted. And we have exit door. Okay, as mentioned, I will stop at the staircase. Okay, any questions so far? Yes. Travel distance with direct distance. Depending on the provided information, travel distance For example, in this case, the direct distance is D1, D2, which is from the corner to the exit door. Okay, D1, D2. Whereas travel distance is D3, D4. Travel from the exit of the room to the staircase exit. Okay. Thank you. Any other questions? Okay, according to my clock, it's 7:49. Shall we have a 6 minutes break? We will start at 7:55. Okay, thank you. Okay, so well, for the reduction factor for Caesar staircase, they are sharing the same shaft, okay, for evacuation. Whereas compared with two separate stairs, should have a reduction for 0.7 as compared with two separate staircase. Because if in case smoke spread through the lift shaft, common lift shaft, there may be a capacity reduction. So C value should be reduced by reduction factor. So it is the maximum capacity of the building over ground floor to be reduced. Okay. Whereas basement is opposite direction, being upward, so it may not allow so many occupants to evacuate or discharge, as the total capacity would be reduced. Now for the exit door, across the exit or into the exit route from a story or a room of capacity exceeding 30 should open in direction of exit, that it's outward. If constructed to open both ways, have a transparent upper view panel. We need to look through with a construction panel, either circle or rectangular or with glazed glass. Fire resistant period or fire resistant rating. Okay, fire resistant rating or fire resistant period. The latest description is fire resistant rating, FRR, which consists of three criteria: stability, integrity, and insulation. Okay, so they depend on the usage and compartment volume in table 2. Okay, say for example, the use is domestic, hotel, office, shops, place of public entertainment, hospital, place of assembly, car park, bulk storage, warehouse, industrial undertaking, excluding the bulk storage or warehouse. So depends on the compartment volume. For example, the atrium, we have fire resistant period, FRR, FRP. Okay, but latest is FRR. So if it is not exceeding 28,000 meter cube, we just need 1 hour for the domestic, hotel, and office. And if it is public entertainment, shops, and hospital, etc., not exceeding 7,000, 1 hour. Exceeding 7,000 and not exceeding 28,000 meters cube is 2 hours. And warehouse, industrial, okay, and we have separate compartment volume, separated 2 hours both. Openings at external wall, okay, adjoining building that is closely packed together, building nearby, okay, another building, for example, in Hong Kong, they are closely packed. For adjoining building within 900 mm imperforate, 900, 1,800. Common boundary, okay. This refers to the staircase width from the street. Common boundary and external wall have half hour by fixed light. We also have the barrier, vertical barrier. So in case of smoke generated, the smoke will be trapped within the certain floor before it spread to the upper levels. Okay. So it helps to buy time to prevent the spread of smoke. Basement, not less than 2 exits, except it is quite low, okay, below 3 meters, not in height, very small, less than 150 meters square, solely or only for lavatory or plant room purpose. Okay. And no staircase serving upper floors should continue direct to basement. As I've mentioned earlier, we should not have the exit or the staircase in continuation. We have separate one. We need to go down and then go up to another places. It should not be continuous. Otherwise, the people run down and they do not find the exit to the ground floor and then go to the basement directly. They should be directional sign, exit signs. At least one exit should discharge independent to another exit into the street. Fire resistant rating, 4 hours. Smoke outlet, okay, 30 meters apart along street footage. Every compartment is needed. 0.5% of floor area and minimum 1 meter. The smoke refers to the smoke outlet. Okay, smoke outlet also sometimes provided at for example, if we have the basement, we have the smoke outlet provided at the perimeter of the perimeter of the building. Okay, so in case smoke generated at the basement, so this is the ground floor, this is the basement. In case smoke generated, we break the outlet and then allow the smokes to come out of the smoke outlet from the basement. MOA, means of access. This includes the access staircase, fireman's lift, firefighting and rescue staircase. We call FRS. F for firefighting, R for rescue, S for stairway. Okay. Not require fireman lift for this criteria. And in the future, if you find some similar situation, domestic office, single staircases, 2 staircases less than 30 meters apart, non-domestic, and place of public entertainment. Okay, this is not personal protective equipment, but public place of public entertainment. Okay, industrial basement. Okay, have a certain cubical meter in the compartment volume. Okay, here shows different types of building. There are access stairways, for example, 1, 2, or more. Number of firemen lift and firefighting rescue staircase, the FRS required. Okay, fire service access point to ground floor. Push open in the direction of exit to outside. Okay, firefighting lift, fireman's lift with an exit distance from the protected lobby, 18 meters. Refuge floor is another part, floor designated especially for refuge purpose. Okay, the roof can be made as refuge. Okay, minimum 2-hour fire resistant rating, provision of sky garden in refuge floor. Okay, now the refuge floor should be provided for all buildings except domestic and composite building. Okay, for example, greater than 25-story at each 20-story interval, or each 25-story interval for industrial and non-industrial purpose. If it is domestic or composite building, you can go back to the FSI code for the definition. 25-story and 40-story in between, the roof can be considered as refuge. And if it is greater than 40-story, with refuge floor. Okay. Now, why refuge floor is being provided? Okay. It can be considered as part of the exit, for temporary and short rest of the occupant, especially if it is super tall building. Okay, they need to have refuge floor in between. So the occupants, for example, evacuate, should be able to take a small rest on the refuge floor, RF. And alternative staircase, so they need to go to tier and then go down again and have an alternative. So in case smoke locked, okay, if this is blocked with smoke, it will not spread to the alternative staircase in one go, okay. Now, place of assembly and temporary safe place for the occupant. There are some requirements during design. No accessible accommodation, no people to stay in the refuge floor, no plant room except a net area greater than 50% of gross floor area of the refuge floor. The clear headroom should be 2.3 meter dimension, served by fireman's lift, okay, FMAN, fireman's lift. Suitable signage and drainage system provided at the exterior of the wall. Okay, drainage system is usually covered, for example, for the openings. We have slits of water like curtain, okay, which covers the opening, which prevents so smoke, for example, getting into the premises. If, for example, another fire occur at the base of the refuge floor, RF, that's the dranger. Okay, this is another illustration on the refuge floor. They have separate staircase. They are not connected together, but through the refuge floor, the evacuation will turn at another stairs. Okay. So they should be free from obstruction and well-maintained signage and lighting. Okay, no obstruction at all. Adequate stimulating features and interaction or interacts emergency sign and voice communication. So notified where is the location of the occupant stay and have good management. Now, the next part is the code of practice for fire safety in buildings. Special concern, okay, the MOE, MOA, and FRC is in parts B, C, and D. MOE, FRC, and MOA. We have part E, which is the fire property of the building elements and components. Some of them are load bearing and some of them are not. Okay, we may have concrete, we may have stone, masons, glasses, etc. Fire safety management is part F, and part G is engineering guidelines. Now for the annex, there are lists of code of practice and guides which cover and issued by the licensing authority for licensed premises. Now for G, part G, we focus on the engineering guideline, fire engineering guideline. Okay, there are several sections, including the introduction, the framework, introduction to fire engineering. In fact, there are some clauses which comply the framework for fire engineering, and they emphasize the fire safety objectives, functional statement. Okay, this may be discussed later. Performance requirement, which is the criteria, and performance relevant performance requirement guidance and demonstration compliance with the code. Besides, there are some evaluation criteria for the guidance to performance requirement. Okay, which is also on MOE, MOA, and FRC and FSM. Okay, the 4 aspects with guidance performance. Okay. And their methodology, fire safety systems, okay, and design, fire safety assessment report, the FSAR, which indicates methods on fire engineering approach for a certain project to be approved and assessed by the authority, bounding condition, computer models, and reference. Now for section 3, okay, which is an introduction to fire engineering, include the relevant considerations and application. We also have safety margin, okay, and safety factor, which is used in the design. Okay. We have the ASET, RSET, ASET, available safe egress time, and the RSET, required safe egress time. Okay, number of and interactions between the compliance of the codes, different methods or alternative methods. Okay, building sites, access, and their forms and construction. Capacity of occupant, means of escape to be affected. What is the hazard? What is the ignition source? The source of heat. Different scenarios. Fire safety provisions, management, fire service intervention, which is related to the provision of firefighting and rescue. Now, regarding the methodology of fire engineering, okay, we look into compliance with the performance requirement. There are different types of assessment methodology, which include the deterministic and probabilistic methods. Okay, and the subsystem, we have 6 of them. Subsystem, okay, SS, which is from the start of or ignition, initial development of the fire. And after fire start, we have the development of smoke, and it may spread, and we need to control or extract it. Detection, warning, and suppression. So in fact, this indicates different stages of the fire, from the ignition stage, the development stage, the growth stage, and the development stage, and decay stage. For fire spread and the impacts and how to control. And the characteristic of the occupant will also affect the methods and the use of systems, evacuation, and fire service intervention with regard to the firemen and fire officers. Designed by fire engineering. Okay, there are different stages of fire using different or applying fire engineering approach. And there are different process, pre-submission, requirement, assessment approach. How large is the fire? We have different megawatts of fire designed as design fire, control of smoke, movement, tenability criteria. So we may also note the amount of, the concentration of toxic gas can be bared or tenable, and the height of the smoke layer, etc., the temperature, etc., for the occupant to survive. Now, the fire safety assessment report. We have the introduction, and as the first items, building usage, okay, and the classification, the characteristics of different buildings and the occupant, whether they comply with the codes, and what is the judgment or justification. For example, we have different trial as design solutions to solve the engineering problem. Assessment of structural performance, not only the active system, but the building's performance, commissioning and field testing using hot smoke tests, especially for atriums. Okay, atriums. We need to ensure the mechanical fans, for example, or the natural operation of the operation of the natural ventilators is functioning properly during the field test. Maintenance and management. Okay. Bounding conditions, information, examples, computer models, which we have validation and verification to ensure that they are correctly used and they perform accurate calculations as designed. Okay, history, etc. Now, next part will be the performance-based fire code for safety. Now, consider the entire building fire building system interaction, which may exceed the prescriptive requirement. Okay, especially as technology advance and also the architectural features may no longer be just rectangular shape, but they have more aesthetic design. For example, the airport or the conventional center or the sports stadium, etc. Greater flexibility in design is needed. And they should also be cost effective. They consider the use of materials, the design provisions, whether the space separation of the sprinkler heads or the detectors, etc., should be noted. Now, a need for clear specification and agreement with the fire safety goals and objectives. And they also mention about the performance criteria in design. So we need to understand how the fire developed start from its initiation, how it spread, okay? And different fire safety measures in installations may help to reduce the occurrence of the fire or the likelihood of fire and reduce the possible fire loss. Okay, for example, a sprinkler, okay, sprinkler operates at a certain, say 68 degrees Celsius for the red bulb. So when the environment attain a certain temperature, okay, it will cause the fire head, the sprinkler head to shatter and water will discharge, okay. So how it helps the fire to be controlled, under control. For example, it suppresses the fire directly. Okay, suppress the fire directly. It also helps to cool down the smoke, okay, which reduce the temperature, okay, and the structural or the resistance of the apartment or the room can sustain a longer duration, and it also helps to prevent the adjacent objects. Okay, it prevents and take a longer time for the fire to spread to adjacent areas, and it also displays away oxygen. Okay, when the water droplets change its state from liquid water to steam, okay, gaseous steam, it absorbs heat and also it changes state to steam, which will display away oxygen. Okay, so this helps to minimize and mitigate the fire loss. Need to understand how the people react. Okay, both human psychology and physiology need to be understood. And for example, the fight and flight response, they may try to evacuate in a calm or in a frightened manner. Okay, they also have others situation, like they may try to search for their family members or friends before they evacuate. So they need to be understood. They also apply credible tools and methodologies and consider acceptable risk, both personal and societal, in designing appropriate measures. Okay, so we have the personal effect and societal effect. So groups of people, they may try to gather before they escape, okay, and verify this acceptance level to be met. Need to consider the financial and societal impacts, okay, the cost, okay, address uncertainty involved in the engineering method, and building safety design in assessment of acceptable risk. Okay, make sure that it is acceptable. Now, for the review of development of the performance-based fire codes, we may have the different International Society of Organization, the Technical Committee on smoke control and to evaluate ability on the fire safety design and meet objectives of the codes. Okay, so different section: smoke initiation and growth, containment. Okay, so as mentioned, starting from the initiation stage, growth stage, development stage, and decay stage. So the initiation, the growth stage with the steepest slope indicating flashover. Okay, fire development and decay. Okay, and we need to consider the containment of fire with passive design and active systems. Passively, we may try to confine it or contain it by partition or wall, like a small room. Actively, we may try to suppress the fire using the fire protection system or fire service installations. Fire threat to people and the environment, and fire engineering, safety engineering. So the organization structure consists of these 4 aspects. Now, how to review of the development? Okay, the first move is in Australia, which lead to the formation of the Fire Code Reform Center, FCRC. Okay, and it is a non-profit cooperation based on facilitating the reform of the Building Code Australia. Okay, and it also have the format by the Building Regulation Review Task Force, the BRRTF. Now, the building code is similar to a draft of the Code of Practice, which provide only the performance-based means of certifying alternative design. Alternative in a sense that besides the prescriptive code, we have an alternative, prescriptive. We have alternative way to provide a similar safety of the premises. And next is Canada. Okay, David Young is a researcher, and the colleagues have the NRCC, National Fire Research Laboratory of the National Research Council of Canada. Okay, so NRCC, which developed the fire CAM, okay, fire risk evaluation and cost assessment method and model as key elements for the performance-based fire code. England and Wales, European, From 1985, the building regulation is being revised and utilize the performance language to allow alternate design again. It shows that it provides equivalent performance using some methods with support and calculations and reasonable methods. Now, core of practice were further developed by Warrington Fire Research and some researchers, okay, and fire experts. New code of practice were issued to establish acceptable levels of risk of life lost. Okay, for example, there are consideration of 1.5 times 10 to the power -5 per person per year for the house. Other places than the house, it's having a less acceptable limit, and limiting also the risks of greater than 10 deaths per incident to a certain value per building per year. Okay, different numbers for different buildings and years. Now to the south, New Zealand, the building codes in 1992 was introduced in a performance-based format. Of the codes, it keep the prescriptive requirements being acceptable. Okay, but support calculations is needed for any occupancy, especially the fire load is greater than 1,500 megajoule per meter square. And there's also a fire engineering design guide, okay, published by the Center of Advanced Engineering at University of Canterbury. Okay, it's decided that the protection of property at regulated occupancy is responsibility of owner and the insurance company. Okay, they need to take responsibility on that. The codes only includes provision to protect property of third parties. Swedish Code 1994. Design criteria within the code document and developing document with functional requirements, calculation methods, with uncertainties. US, okay, 50 states derive the activities from the activities of number of private codes and standards organizations. NFPA, you have heard the Association of the States, which published the Life Safety Code NFPA 101, okay, which based on different occupancy and characteristic of the occupants inside buildings. SFPE, Society of Fire Protection Engineers, okay, it's being considered. Now, what is performance-based regulatory system? And what is performance-based code? Okay. What happens to prescriptive requirements? And how is compliance with the performance-based codes being determined? Okay, this may be some of the queries that we may have in mind. And the codes itself have the societal goal and some objectives and performance requirement. There are acceptable solutions and options to comply with the codes. We need to evaluate whether the design is matching or provide sufficient safety for the occupant. And there are different tools, for example, simulations, evacuation tools to simulate the situation with different numbers of occupants and see whether the required safe egress time is within the acceptable safe egress time. Okay. Now the concept, okay, the requirement of the code refers to what should be done. Now, acceptable means for complying with the requirement. How should it done? Okay, what is the requirement? How can it be achieved? Acceptable means of verifying whether the proposed solution comply with the code's requirement. How it can be verified? How to ensure that it is acceptable? The triangle, okay, shows different layers. As we have the goal as the top functional alternative, personal performance requirement. Okay, and the goal, the performance functional objective, performance requirement, sorry. It's different layers, okay? We deem to satisfy with the alternative requirements, and there is a performance-based alternative. So deemed to satisfy alternative is referring to the prescriptive, whereas the performance-based is the fire engine approach. Okay, both have the performance required. Now for the codes and standards, okay, we have the regulatory motives for analysis and design of the fire safety measures. So the building codes required acceptable level for the fire. Okay, how large is the fire size, for example, and life safety is the fire safety objectives, of course, to protect human lives. Okay, and it is not a means for compliance. And it also need to identify some acceptable methods, some ways. Now for the codes, as mentioned, we have the society goal, objectives, performance requirement, performance criteria. So this in fact reflects the maker's interpretation of the society explanation to health facilities or the safety level in the buildings. Now for the society goal, it is meant by defining the general statement which relates to safety in the building. Okay. This general statement may considered with respect to the health and facilities inside the building and what the society expects the building. For example, safeguard people from injury due to the structural failure. Okay, this is listed in the building regulations. Okay, it is just a general statement indicating the people should be protected from any injury and not injured by the structural failure or collapse. Functional objective, okay, it is described in more details how the building and the system will function to achieve the goal. Okay, how to achieve this. For example, okay, again, the building regulations, Wellington, New Zealand. Building is to be provided with safeguards to prevent fire spread, so the occupant have sufficient time to evacuate to a safe place without being overcome by the effect of fire. no suffocation, no block of exits due to smoke or fire or heat. Okay, so it is in the longer description and considering the function. Now, for the performance requirement, it is even a more detailed statement of the level of performance that should be met by various parts, materials of the building, assemblies, systems, components, and design factors. So it helps to evaluate how the building and design features will meet the goal and functional objectives. So this is also the reason why we have the triangle. Okay, one after another. Okay, the goal, okay, described in more details with alternative solution, function, performance requirements, etc. Example of the performance requirement, slide 79. Materials and assembly may resist the spread of fire to limit the smoke generation and heat generation. Toxic gas may be produced to an appropriate degree. Okay, so we need to have qualitative terms and avoiding ambiguous ones. Okay, travel distance, number and mobility of the occupant, building usage, active fire service installations, or safety systems installed in the building. Okay, so it is more specific to the performance requirement, okay, on how to resist the spread of fire and limit the smoke and heat spread and generation. Now, for the performance criteria, it is acceptance criteria that may be provided in the code. Okay, some are the standards and some are in other methods, and take them as a reference. Okay, and some even in absolute values. Examples. Okay, examples of acceptance criteria. Say the level of fire gas or the hot smoke shall not be lower than 1.6 plus 0.1 times h, where h is the height of the room, as stated by the Swedish Board of Building, okay, the Housing and Planning, Building Regulations, Sweden. Another one, limiting the conditions of tenability caused by radiation, okay, with a higher temperature, heat released in radiation method and means of heat transfer. Less than 2.5 kilowatt per meter square can be tolerated over 5 minutes. Or another one, tolerated for 30 seconds, 10 kilowatt per tolerated for 4 seconds. Okay, by fire engineering guidelines. Let me check. Okay, this is 2.5 and this is also 2.5. I check whether there is a typo there. Okay, because this is 10 kilowatt for 4 seconds. Should be increasing, okay, in the heat radiation. Well, but this is less than, okay, less than 2.5 for 5 minutes, whereas 2.5 is 30 seconds and 10 kilowatt per meter square is 4 seconds. Now for the performance criteria, okay, several performance criteria is applicable to single problem. We may try to select the criteria with dependent on situation. Okay, in different acceptable method, not in the code, and knowledge required to develop performance criteria may not exist, okay, because they are not sensible to regulate criteria with the scientific basis being uncleared. For the standards, okay, it is a consensus document with set of rules, okay, conditions, and the requirements also have definitions, classifications, delineations, specifications of dimensions, etc. Okay, so it is a measurement of both quality and quantity to describe different methods, different materials, products, systems, etc. Okay, there are different description further on the property of material, whether it has sufficient strength, okay, elastability, durability, combustibility, etc. What is the amount of heat release? It is durable. Dimension, pipe thread size, the diameter of the pipe, internal and external of the pipe works, diameter of the pipe works. Test procedures, how the strength, the frame spread, and electrical mechanical compatibility being tested. There are methods and procedures for installation, testing, and commissioning, and maintenance and operation, etc. Okay, and terminology also required. Now, most current building system related standards are the prescriptive based or specification based. So it's stated clearly what types of building usage and what systems should be used and what is the specification. Say, take hydrant and hose reel as an example. We may try to limit or specify the performance of the hydrant outlet. Okay, for example, it need to be of a certain height above the finished ground level. It need to have pressure and flow rate of specified range. Okay. Another example is the distance between the sprinklers. Okay, limit to 3.7, not less than 2.4. Okay, with large droplets. Okay, as compared with water mist, which is finer droplets of water. Okay, so the sprinklers should not be too far away or too close together. If they are too close together, there may be a case of re-wetting each other, which is not favorable. Okay, if it is too far away, the coverage may be having some empty space that is not overlapped. Okay, which is also not good. Performance-based system less emphasize on prescribed spacing of the dimension. Okay, so if it is performance-based, we do not specify specific distance, but more emphasis of the performance of the system, whether it can achieve the objective or the functional objective of the sprinkler system to attain life protection or inhibit of the fire spread. Okay, more emphasis on the components in meeting the objectives of the code. There are different acceptable methods for the engineering standard or engineering practice that is developed in a consensus process. Qualified engineer, educator, and researcher are involved, and they have reality check by broader building and fire community. So large number of buildings will be taken into considerations in surveys studies. Each automatic sprinkler system required another section of the code to be installed according to the NFPA 13, which is a standard for installation of sprinkler, which is an example. Okay, computer fire model or modeling as a design tool, okay, or evaluation. Okay, peer review. Different parties or different researchers will be involved with challenge to the certain tools, okay, to ensure it is valid and verified. Developed in or received positive evaluation on consensus process among, again, qualified engineers, educators, and researchers, and they are positively evaluated. Make sure that they have ability to generate outcome, which is consistent with those claimed by the developer. Okay, so this is evaluation to make sure that what is generated from the tools are consistent, which is having the same outcome as the claimed by the developer. Okay, acceptable solutions. Comply with the three main the goals, the objectives, and the performance requirement, often called compliance options in regulations. They can be specific solutions in the COCs or performance-based solutions, which have different methods being provided in the COC. So for the accepted or acceptable solutions, they are deemed to comply before its use. That means they need to be ensured to comply or to get the same performance as the prescriptive COCs. And solution from the acceptable method still need to verify for compliance with the COCs. Now for modeling. Okay, computer modeling in fire safety engineering design is not simple. We need to understand the physics, chemistry of enclosure fires. Okay, for example, what you have studied in fire dynamics, BSE 533 may be useful. It's to assess the validity of the result and also make sure that the simulation result is accurate. And there are different types of models available in the market. Some are the probabilistic model, some of the deterministic models. Okay. Probabilistic model includes the network model and the statistical model, whereas more often we will consider zone model or field model. CFD, computational fluid dynamics model, are commonly known. Now for the probabilistic model, okay, it relates to the building fire safety, which do not make use of the physical and chemical principle involved in fire. Okay, some statistical predictions are made. Consider changing from one stage of fire growth to another. As mentioned, the stages, okay, from different stages of fire. The cause of fire is described as a series of discrete separate stages, based on experimental data and incident statistics, and they are derived time-dependent probability for possibility of the fire changes in different stages. Network model, okay, usually consider some graphics presenting the path and routes. There are some, some event tree, fault tree analysis, decision trees being made. And for the statistical model, describe random phenomenon, okay, and with probability distribution based on historic data, engineering evaluation, or both of them. Now, One of the common simulation models with the Monte Carlo simulation, it involves the fire development, okay, and determine ignition, flame spread, fire load, and ventilation. And you may know sometimes in the fire stages, it is fuel or ventilation control fires, and the computer program will also randomly allow the fire to progress from one defined stage to another one and study importance of the parameters. Whereas for the zone model, okay, zone model, you may consider try to divide the room or compartment into two zones. One is the upper layer and the other is the lower layer. Okay, two zone or two layer, two zone model usually called. Conservation equations in considering there is a point source, the mass is transfer is conserved, and other conservation equation is considered through the lower zone to the upper zone, with the fire plume being considered in a inverted cone. Okay, and estimate various transport and combustion process in between. So this is the hot smoke layer, usually. Upper layer is having hot smoke. And with its high temperature, density will decrease and it will rises to the top. Whereas there is air entrainment, it's a lower layer, okay? Cooler air available. And usually openings are should be provided at lower parts. For the room fire, okay, normally we have the fire occur, for example, at the polyurethane solver, okay, with air entrained and smoke plume is considered. And when it hit the ceiling, there is a ceiling jet spread radically to throughout the whole compartment. Okay, so the smoke layer gradually formed. Okay, and when with the hot smoke layer, it's considered two zones, hot zone and lower zone. One is hot and one is cold. And with the mass transfer, okay, in between the fuel and the hot smoke layer, we have the control volume as stated in the two-zone model. And the fire itself is a source of energy. It's the mass, okay? The plume, the fire, this is the plume, is to transport the mass, okay? Transport the mass to upper layer from lower layer or from lower zone with entrainment. Entrainment, with the hot air, okay, with less density, it rises, and a temporary vapor will occur, and adjacent air will entrain into that vacuum and replace it. Okay, so and larger volume of air will increase, resulted, okay, with the smoke plume increasing in smoke size and volume. And main assumption is made. The gas is treated as ideal gas. That means with constant molecular weight and constant specific heat, Cp and Cv. The zone model also exchange the mass, okay, with three boundaries because of pressure difference and shear mixing. Combustion, treated mass and energy source. The plume is instantly arriving at the ceiling. The boundary, we have the opening. The room content have mass and heat capacity being ignored. Okay, so this is also an assumption. No absorbed of heat. Horizontal cross-section of the enclosure being a constant area. Pressure is uniform. Mass flow is turbulent entrainment. Okay, so it have a turbulent flow of air entrained into the foam. Fluid friction effect at solid boundary are ignored. Major problem, too clear structure. Okay, but actually there is some transfer in between these two zones, not just through the plume, but there may be others. Okay. So these are some of the assumptions. One of the two zone models, we call it HARSET-1. It is developed by the National Institution of Science and Technology and calculates the development of fire effects with thermal, toxic gas, and smoke with respect to time. CFAST, okay, is another model which is consolidated fire and smoke transport. Okay, it is a popular two-zone model developed by the Buildings and Fire Research Laboratory, also from NIST. Now, it helps to simulate the smoke movement up to 18 connected rooms. FastLight, okay, fire growth and smoke transport, combined computer package with FPE2 and CFAST, but limit to 3 rooms only. Now, after zone model, we have the field models. For the field models, it involves some finite differences method and finite control water method. There are some partial differential equation, for example, the Navier-Stokes equations. It involves turbulence, radiation, and combustion, which are 3 sub-models which need further investigations. Field models have limitations because the physical principle behind the turbulence has to be reviewed. And the scheme for discretization of the set of equations need to be considered carefully. Algorithm involved the pressure-linked equation, treatment of boundary conditions, and results have to be compared. Okay, more or advanced knowledge can be learned from your computational fluid modeling subject, which is BSc 531. Okay. Okay, the next part will be example, but I am thinking that I reserve this example to next lecture. And for the rest of the time, I would discuss the assignment with you. Do you still want to have a 5 minutes break? No need. Okay, let's start the assignment early and hopefully we can end a bit earlier. Okay. So far, do you have any question on the 6 sections of this topic? Okay. Any questions? Maybe need some time to digest. Okay, let me see. So in case if you have any questions, you are welcome to ask me after class or during the break or through emails. Okay. Now today I will release assignment 1 topic, which consists of a case study report. Okay. I have uploaded to the Blackboard Okay, just in case you cannot find it, I lead you to the assignment. So under the under 534 legislation aspects of fire safety management, assessment. Okay. We have assignment 1, individual case study report. And within which each student, okay, will do the report, and there are basic several steps. First, you are required to choose your own workplace or commercial premises or site office for a case study. Okay, I know that some of you are full-time students who do not work in any workplace, but you can consider to use PolyU campus, such as the library or the V Core or any other premise to do your study. Okay. Describe the usage and occupancy of your chosen workplace, whether it is a commercial building or it is a hotel. Okay, just in case you are working in the hotel management office or other office or the building in PolyU. List the type of combustibles and furnitures available. Desk, wooden desk, PolyU, sofa, other like carpets, etc. Types of occupancy and their activities. What are they doing? Okay, attending classes, lectures, or slipping risk, or mobility, including those in wheelchairs, etc. Estimated number of occupants. So depending on, for example, the occupant load factor, for example, 9 meters square per person. Still remember the occupant load factor used in office. Okay. Provision of active fire service installation. Okay, that is, or that can be observed, like sprinkler heads or the recess type, or alarm belts, exit doors, which is the passive design and layout. Okay. Try to state the current fire safety management strategies in the chosen premises. I understand that some company has its own fire safety management plan or fire safety management scheme, which may be in a booklet, okay, or in some publications. If there's already a fire safety management plan for your premises, try to describe the existing elements, okay, how it is being covered. Suggest if there are any missing parts for existing fire safety management plan. If there's no fire safety management plan or not known, okay, you do not know whether there is a plan, try to develop one for your premises using the Code of Practice for fire safety in buildings 2011 issued by the Buildings Department. As you know, the Codes of Practice for fire safety in buildings is available. And remember, part F is on fire safety management. But I'm not asking you to direct copy of all the items. But for example, in maintenance plan, what do you need to focus on for your particular area or the particular office? Depending on the fire load present or combustible present, and depending on the occupant characteristics. Okay, office A should be different from office B. Okay, they may have different fire load or areas or number of occupant. Training plan. Okay, are the staff being well trained, or are there any transient, that is the people just come over for a short time and do not know the environment well? Fire action plan, what should be done in case of fire start or a fire occur, okay? So you may read through the document, part F, okay, in more details to get the idea. And discuss the reason why accidents still happen, even the fire safety management strategies are provided, okay? If we have a good plan, it's to suppose that the fire or the risk will be low, okay, the fire occur, but still accident happen. Why? Propose how to solve the problem and prevent the accidents from happening, and how to make sure that the plan is real implemented. Okay, sometimes including increasing the fine or try to have a penalty. Maybe, I'm not sure, you may propose it and discuss the effect. How to implement the plan, have real implementation. Provide supporting documents and materials such as photos, figures, tables, organization chart, if any, for your chosen premises, okay, or the evacuation layout plan, etc., can be included in appendix. Okay, submit item 1 to 5. That is the main report. 6-page main report, and item 6 in the 4-page appendix to support your work. Okay. So the submission will be a soft copy of the individual case study report in a single PDF file in the Learn at PolyU. I later will create another link for your submission at Blackboard under assessment. Okay, I will create a link through the Turnitin LTI. The single PDF file possesses the cover page. So you have your BSE 534, legislation aspects of fire safety management, your name, your ID, and label it at the individual case study. Okay. 6-page main report, 4-page appendix. Okay. Single page, okay. 6 single page main report, 4-page appendix. Reference list, if any. Okay, if you reference to the codes of practice, you may include it in the reference list. And declaration form. Okay. Now the report shall be written in English, printed in A4 size page or paper. Not less than 12 times New Roman font. Okay. Please not too small, otherwise I need to enlarge the page a lot. Okay, I'm getting old. In the assignment, you can use generative AI tools. It is allowed and permissible. And you are required to declare specific use of AI tools in your work. Okay, later we will go through the declaration form at the end. Noted that declarations are not a substitute for proper referencing in the submitted work. So you need to quote special reference, if any, in your report. Okay. Now, report will be marked according to the organization and structure, 10%. Okay. Nowadays, the Gen AI tools may help having a well-organized report. So 10%. Technical content, okay, need to depend on your findings from your workplace and PolyU campus buildings, etc. Discussion and solutions and suggestions, which is related to, for example, proposed method to prevent accident from happening, how to have real implementation of the plan, and relevant photos, figures, and tables, supporting documents, 15%. Okay. Assessment criteria. The rubrics is listed for A, B, C, D, and F. Okay, with different percentage assigned. Okay, and the honor declaration form, I have filled in the subject code assignment and submission date for you already, 13th of October, 2025. According to the plan, submission of date is week 7. Week 7. So I will try to adjust the time to 1 minute before midnight in the submission. And you declare the submission, you sign the name, sign your signature, student name, and ID, and declare what way you have used the Gen AI tools to brainstorm or generate ideas, create structure, improve clarity, check grammatical mistakes, etc. Okay, you have the names and ID and signature again. Okay. So I suppose that each of you will generate a report for submission. Okay. Now your senior classmates may have generate reports in previous years, but some of the items have been changed. So I try to pay attention, recognize the items to see the difference, okay? Because in previous years, some students directly copy from previous classmates, and I find it, and marks will be deducted, okay? Try to pay attention to that, okay? Any questions about the layout and submission requirement? Okay, if not at the moment, thank you for your attention. And we will continue part 2 of the performance-based code next time. Okay. By the way, I have already uploaded the documents in the content. Okay. Lecture 1 to lecture 5 for my parts. I think Dr. Wang have also uploaded lecture 6 for her part. Okay, so I have heard some of you would like to print it in advance, so you can do it up to lecture 6. Okay, any other questions? If not, you can leave and have a good night. Okay, thank you. I will stop the recording.